Alright, so we're going to go through a little tcap review right here. We have a marble pouch, and the pouch has different colored marbles. It has red, yellow, green, orange, and blue. And we have 8 reds. I can count them. We have 6 yellows. I have 3 greens, 4 oranges, and 3 blues.
Why did you do that orange marble for orange?
Oh, it can be the same color. So if I add them together, I get a total of 24 marbles. So what are my odds of getting a red? My odds of getting a red are going to be the number of reds, 8, over the total in the bag. Now, in probability, you have to reduce, so we reduce this to 1/3. For yellows, same idea, 6 over 24. So I have 6 in the bag and 24 total in the bag, and so that is 1/4. Then for green, I have 3 over 24 is equal to 1/8, because that reduces to 1/8. It was looking a lot better on you. Orange is going to be 4 over 24, which is equal to 1/6. Anya, keep going. You're doing really good. She's picking up garbage off the floor. That's good enough for 2. And then we have 3 over 24, which is equal to also 1/8. Now, the question of if I have 8 marbles, how many would you expect it to be red? That's sort of an interesting question, because if I had drawn 6 marbles, I'd definitely expect that 2 of them would be red. If I drew 9 marbles, I'd expect to get 3 reds. 8 is closer to 9 than it is to 6. So to be honest with you, I would expect 3 marbles, although theoretically you'd expect 2 2/3 marbles, but that doesn't make much sense because you can't have 2/3 of a marbles. Finally, what are the odds of getting 2 yellows? So there are a couple ways we can do this. One of which is to make a counting tree. Anya, can you please go down and open the door for Campbell? That would take bloody forever, right? Thank you, Anya. So the other way to think about it is I have a 1/4 chance of getting a yellow. And then if I put that marble back in and draw again, I have another 1/4 chance. This will give me a total of a 1 in 16 chance of pulling. Go down and open the door for Campbell, okay? Of drawing 2 yellows in a row. All right, which has a greater volume? Now, this one comes down to finding the volumes. And I know the volume of a cone is going to be 1/3 of the area of the base. In this case, it's a circle, so the base is going to be pi r squared times the height. For the cylinder, it's just the area of the base times the height. And so we have to plug in the numbers. So I have pi times 4 squared times 8 over 3. So I have pi times 16 times 8 over 3. Now 16 times 8 is 128 pi over 3. Now, I don't really want to multiply out pi, but I should go ahead and divide the 3. So this is equal to 42.6 repeating pi. I don't have to multiply the pi because they both have pi, right? Over here, we have pi times 3 squared times the height, which is 6. We have 9 times 6 pi. 9 times 6 is 54 pi. Now, 54 is definitely bigger than 42.6. So therefore, I know the cylinder has the greater volume. Finding the surface area of the box and the volume of the box. So you know the volume of the box is the area of the base times the height. In this case, it's a rectangle. So the base is 4 times 8, which is 32. So we have 32 times 5, which is equal to 160 inches cubed. Now for the surface area, the easiest way to do it is the surface area smiley face. Or you could find the areas of all the faces. So for instance, this is 4 times 5, which is 20. This is 8 times 5, which is 40. And then the top or bottom is going to be 32, because that's 8 times 4. Good job, Anya. Put it in the garbage. So then for the smiley face method, we have 4 times 8 times 5. Multiply the answers by 2. So we have 32. Over here we have 40. And here we have 20. So add those together and I get 92. 92 times 2 is equal to 184. That's in inches squared. And for my last 2 problems, I'm going to start with the bottom problem first. It's still rise over run, but when the scales are different, you have to actually find the rise and find the run. So I'm going to find 2 points that the line definitely goes through. So what's the difference from here to here? What's the vertical change? We're going from 0 to 200, so the vertical change is 200. The horizontal change is 35. So my slope is going to be rise over run, 200 over 35, which is equal to 5.71. Anya bumped her head. Are you going to be okay, Anya? Why don't you come over here and I'll kiss it? Because a daddy kiss always makes things better. And then the volume, or come here. And the y-intercept is 0, so my equation is y equals 5.7x.
It's right here.
Oh yeah, that looks like it hurts. Is that better? Yeah. I'm sorry, Anya. Why don't you have a seat? You'll be okay in a second. Now for my other equation. I have a y-intercept of 75, so I can squirrel that away. And then I see that it goes through here. So the vertical change is from 75 into 125, so that's a vertical change of 50. I have a horizontal change of only 25, even though obviously it looks a lot greater. So I have a slope of 2, 50 divided by 25. Now for my line of best fit, my scatter plot. Now, it's a little tricky. Here's 1, here's 1.5. So that looks like that's a y-intercept of 1.75. And then what I'm going to do is I'm going to take my 2 and my 4. And this is going to involve some degree of estimation here. So I'm going to say my horizontal change is 2. I mean, that's pretty easy. But I'm going to say my vertical change here is about 1.5, isn't it? Because this is 5. This is 3.5. 3.25. So I'm going to estimate the vertical change at 1.5. So I have 1.5 over 2x. Now we don't really like to have fractions inside fractions, so I'm going to multiply my slope by 2. And you know that you can multiply the numerator and the denominator by the same number and get an equivalent fraction. So we have 3 over 4x plus 1.75. Now the fun thing is, it actually gives you the answers here. The actual y-intercept is 1.73, and the slope is actually 0.78. I got pretty close to that by estimating. Not too bad, huh? Oh, I forgot the y equals.